Mumbai Ahemadabad Bullet Train Corridor.
Namaste.
Namaste.
Welcome to India on Fast Track, the Mumbai Ahmedabad Bullet Train story. I'm your host, Deepika Upadhyay, and today we dive into one of India's most ambitious and transformational infrastructure projects, a project that is set to redefine speed, engineering, and connectivity in our country. The Mumbai Ahmedabad high speed rail corridor is not just a railway line, it is a symbol of Viksit Bharat, a confident future ready India embracing global standards of mobility and engineering excellence. From advanced tunneling techniques to cutting edge electrification, from state of the art stations to the promise of economic transformation, this corridor represents the next chapter in India's growth story. To take us through this remarkable journey, we have with us Dr. Naresh Bana, a highly qualified, respected expert in the field whose work and insights have deeply influenced modern transport and infrastructure planning in India. Dr. Bana, we are honored to have you here with us today. Thank you for joining.
Thank you, Deepika ji.
Dr. Bana, to begin with, could you give us a broad description of this project?
Deepika ji, the Mumbai Ahmedabad Bullet Train Corridor, as rightly described by you, is the symbol of Bharat having arrived in the field of infrastructure. This high speed corridor spans 508 kilometers and which has 465 kilometers of viaduct, 25 river bridges, 28 steel bridges, and 21 kilometers of tunnels, which includes 8 mountain tunnels and 12 state-of-the-art stations and 3 rolling stock depots. In order to expedite viaduct construction, Indian engineering giants have used the full span girder launching technique, which is first in India, and very few countries in the world possess that. This method is 10 times faster than the conventional method of launching bridges. Each full span 40-meter girder which weighs almost 1,000 tons is launched within a less than 24 hours. Heavy indigenous machinery is being used for constructing the viaduct. The big cranes, the big gantries, they lift the box girder with precision from the girder transporters and place it between the two piers with use of full span launching technology. And as I said, in 16 hours or so, you have a 40-meter span ready. So nearly 325-kilometer viaduct has been already constructed, and which has more than 4 lakh noise barriers on both sides fixed already on the viaduct. Overhead electrification is also moving along with the same speed and is being installed over the viaduct. For the first time in India, the J-slab ballastless track is being implemented. The entire track installation is being undertaken using machinery especially designed and manufactured to Japanese specifications. Bridges across the 25 rivers are progressing rapidly. In addition, 28 steel bridges are being constructed to cross highways, expressways, and railways along the corridor. The fabrication of these bridges is being carried out in 6 dedicated workshops located in various parts of the country. The bullet train route features 8 mountain tunnels that are being constructed using the new Austrian tunneling method. And one of the most remarkable part of the bullet train project is the 21-kilometer long Mumbai-Thane tunnel. The list is quite long and I can go on.
Thank you for that overview, sir. How was the Mumbai Ahmedabad high speed rail corridor conceptualized, planned, and being executed? We would also like to know about the overall cost and financing.
Actually, the project is the brainchild of our Honorable Prime Minister, and as per his vision, this was conceived and the Japanese funding was agreed to in principle. And in 2016, National High Speed Rail Corporation was set up under the Companies Act with an object to finance, construct, maintain, and manage the high speed rail corridor in India. This is a special purpose company for this project only, and it's a joint venture between the central government and the state governments of Gujarat and Maharashtra. The estimated cost of the project is INR, that is Indian rupees, 108,000 crores, which is almost US dollars 17 billion, which excludes taxes and is being executed with the official development assistance loan from Japanese International Cooperation Agency JICA. About 81% of the total cost of the project will be funded by the government of Japan through JICA. The remaining project cost will be funded by the government of India. According to the equity structure of the special purpose company, 50% is held by the government of India through the Ministry of Railways and 25% each by the governments of Maharashtra and government of Gujarat. The majority of approved funding for the Mumbai Ahmedabad Bullet Train project is from the JICA through the ODA loan, as I mentioned. The tenure of the loan is 50 years with a moratorium of 15 years.
Sir, you also mentioned earlier about the span construction method and the engineering approaches used. Can you share more about the key construction highlights of this project?
That is something very interesting. And I will just share three of the interesting highlights which will be of interest to our viewers. Firstly, I wish to focus on the construction of substructure and superstructure. That is the viaduct, the bridge-like structure which you see running through and through. And the norm generally has been in this project M40 concrete for the substructure and M50 for the superstructure. Whereas for a similar structures in other parts of the country, M30 or maximum M35 is used. See, the difference is it becomes very complex when you go to M50 because concrete is a exothermic, concrete hydration is exothermic reaction, and the time to reach peak temperature depends on the cement type, water concrete water cement ratio, admixtures, and ambient conditions. Generally, for standard concrete, say M30, based on the mixes you see around the city, the concrete mass reaches its maximum temperature within 24 to 36 hours. And this temperature could be maximum up to 60 degree, right? But in the case of M50, it could cross 70 degrees, and the code says that beyond 75 degrees, if the temperature goes, the peak temperature crosses 75 degrees, there could be internal cracks and the structure may fail. So to ensure that the peak temperature of the concrete remains in limits, the chilled water is used for preparation of the concrete. Water temperature is 5 degrees. So it's called cold concrete. And then it is transported and then it's pumped and put in place. So to ensure that within the stipulated time, the peak temperature does not cross 70 degree. Right. So this is how the concrete is prepared and utilized. So this is very interesting and in such a large project. Secondly, the full span launching method, which I mentioned earlier also. So about 90% of the alignment is elevated and is being constructed mainly using this full span launching method. This unique construction method is being used for the first time, and India is one of few countries in the world to use the master this technique. So as I did mention, that is 10 times faster than the conventional segmental construction technique, which is used for construction of viaducts. And thirdly, the methods of tunneling. The Mumbai Thane tunnel, which is 21 kilometers, is unique in a way that it includes a 21-kilometer total tunneling section, out of which 5 kilometers is using new Austrian tunneling method, and rest is using the tunnel boring machine with the largest dia head, cutting head, which is 13.6 meter diameter, which is, you can imagine, that is the width of the tunnel at any point. So these are the some of highlights which I'm sure the viewers would find interesting.
Another aspect everyone is curious about is the stations and the actual travel experience. What can passengers expect in terms of station design, amenities, and the journey itself?
Deepika ji, that is very interesting. After all, it is the passenger and the users who are going to grade the better or worse of the project. And facilities for them, whether it is coach, whether it is the stations, are being designed and constructed in keeping with the local cultural sensitivities as well as the modern technical standards. And the trains for this corridor are state of the art with consideration for comfort and reliability. The trains are being designed to suit Indian environmental conditions. There are 3 rolling stock depots at Sabarmati, Surat in Gujarat, and Thane in Maharashtra, which are under construction. The design of each of the 12 stations on this line will reflect the spirit of the city where it is located. This will bring about the instant connection with the local population and promote a sense of ownership of high-speed rail systems. The stations are being designed with contemporary architectural facade and state-of-the-art modern finishes. For a seamless travel experience, the stations on the alignment will be developed as transport hubs connecting with other modes of transport. And thereafter, the passenger would be able to smoothly transit from bullet train to metro to bus to railway to airport and provide hassle-free connectivity. It would reduce the travel time, enhance accessibility, and promote the use of public transportation. In order to enhance accessibility and convenience of commuters and to promote economic activities around the station, we have seen that the transit-oriented development has been planned. That means the areas around stations at Sabarmati and Surat in Gujarat and Virar and Thane in Maharashtra have also been shortlisted by the respective state authorities for preparation of station area development schemes. Basically, they would involve the value capture as the area around develops. So some part of the value will be taken in to make this project more financially better. I won't say it will become financially bankable or viable, but yes, there will be some revenue stream plowed back into it. To achieve seamless integration of various transport modes, a multimodal transit terminal has been constructed connecting Sabarmati Bullet Train Station in Gujarat with various modes of transport like the metro, BRTS, railways, etc. And not to leave out the energy requirement. To meet the energy requirement, 12 traction substations, 2 depot traction substations, and 16 distribution substations are being built, and it will be a fully electrified corridor on the lines of Shinkansen.
And finally, Dr. Bana, how is this high speed rail corridor aligned with the vision of Viksit Bharat and Atmanirbhar Bharat? In what ways will this project contribute to national growth, innovation, and self reliance?
Deepika ji, the bullet train is not just a bullet train, it's an entire ecosystem of a best of precision, quality, versatility, and technicality. The systems and technicalities are of the airlines or aircraft grade. It is therefore it has created a whole lot of industry and technical uh, ecosystem around it. It is stimulating economic growth by creating jobs during construction and during operations, while also it has attracted investments into various ancillary units and structures and revitalizes areas around stations. By improving mobility and connectivity, bullet train will shorten travel time between cities, enhancing worker productivity and fostering business collaborations. It is also going to facilitate connectivity between smaller cities without airport, which do not have airport infrastructure, such as Vapi, Boisar, Bharuch, Anand, Nadiad, to major urban centers like Ahmedabad, Mumbai, Surat, and Vadodara, which will contribute to more balanced regional growth. The project resonates with the PM's Gati Shakti initiative of transforming India's infrastructure and connectivity to build a Viksit Bharat, Saksham Bharat, and Sashakt Bharat.
Dr. Bana, thank you for sharing such valuable insights. Your explanations have not only expanded our understanding of the Mumbai Ahmedabad Bullet Train project, but have also shown us the depth of engineering, planning, and vision that goes into creating a world class high speed rail system. For our listeners, this corridor is more than just fast travel, it represents India's technological leap forward, a powerful step towards Viksit Bharat 2047 and a testament of the spirit of Atmanirbhar Bharat. Namaste.
Namaste.